Good afternoon. This lesson is done with no kids in the class or students in the class. This lesson was done this morning. However, for some reason or other, the mic wasn't being picked up by the program. So I'm going to redo this lesson. However, again, there's no kids in the class, so there is no kids interaction in this lesson. Okay. So basically at this point we got until the homework was exercise 1 on page 310, the even numbers. Okay, so this is exercise 1 on page 310, the even numbers. So we're consider the word Florida. You are required to form different 7-letter word arrangements using the letters from the word Florida. The question is, how many possible word arrangements can be made if in the first case the letters may be repeated? So if the letters may be repeated, from here we know there are 1, 2, 3, 4, 5, 6, 7. There are 7 letters, so there are 7 bits. 2, 3, 4, 5, 6, 7. The letters may be repeated. I have 7 options on the first bit, 7 on the second, 7, 7, 7, 7, 7. So in other words, we have 7 to the exponent 7. And 7 to the exponent 7 is 823,543. Okay. Look at the next one. D. The letters may not be repeated. So here, again 7 bits. So how many options do I have on the first bit? 7. Then 6, 5, 4, 3, 2, 1. It gives us 7 factorial. Now last lesson we discussed the factorial already. So it's 5040. Let's carry on. That was number 4. They want to know how many different ways are there of predicting the result of 6 soccer matches, where each match can either end in a win or a loss. So 6 matches, so 6 bits. So how many outcomes are there in the first event? 2. Second, 2. Third, 4th, 5th, and 6 is all 2. So it's 2 to the exponent 6. Okay. And 2 to the exponent 6 is 64. Alright. We done number 5 already. Number 6. Number 6, there was indication that there was a problem with this question. So A. There are 4 bus lanes between town A and town B, and 3 bus lanes between town B and town C. We've got A, B, and B to C. How many ways can a person travel by bus from town A to town B? Town C, sorry, by way of town B. So from A to B there are 4 ways, from B to C are 3 ways. So in other words, that is going to be 4 times 3, which is 12 ways. B. How many ways can a person travel return trip by bus from town A to town C by way of town B? Return trip from A to B, so 2, there are 12 ways, and return, coming back, is going to be times 3 times. From C to B is 3 ways, and from B to A is again 4 ways. So it's 144 ways. Now even looking at C, C says now how many ways can a person travel the return trip by bus from town A to town C by way of town B if the person doesn't want to use the same link twice. So going from town A to town B, there are 4 ways. From B to C are 3 ways. Now return trip from B to C, they're using one of the ways. So I'm left with 2. And from B to A, I'm using one of that, so I'm left with 3. So that would be 12, 24 is 72. Combination of 72 routes possible with that information given. And this is when we spoke about factorial notation. We see that the product of 6 times 5 times 4 times 3 times 2 times 1 can be written as 6 factorial. In other words, 5 factorial is 5 times 4 times 3 times 2 times 1. 9 factorial is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. N factorial is n times 1 less than n, then 2 less than n times 3 less than n, all the way to 3 times 2 times 1. Also, very important to note that 0 factorial was 1. Now, I've also indicated here that by deduction, we know that x to the power 0 would be 1, and this was proven in grade 8 or 9. This here, I'm sure there's a way of proving it, however, I don't know. If you're that kind of guy that wants to know how, you can, I'm sure, Google it. And they can prove to you why 0 factorial is 1. But it's not required for our situation we will be finding ourselves in. Example 5, consider the word park time. We have dealt with this before. You are required to form different 8-letter word arrangements using the letters from the word park time. How many possible word arrangements can be made? The letters may not be repeated. This we've dealt with this already. It's 8 letters. So there's 8 options. Since 1 is used, letters may not be repeated. 7, 6, 5, 4, 3, 2, 1. Which is simply 8 factorial. So it's 40,000. Okay. Look at example 6. I want to know in how many ways can 6 different people be seated. That was example 5, so this doesn't belong here. That's example 6. Example 6 on page 311. In how many ways can 6 different people be seated in the first 6 seats in a movie theater? So, how many bits are we going to have? 6. Okay. At any time when you feel that you want to do the sum, which is encouraged, just pause the video, you do the sum and you carry on watching. Okay. So, there are 6 different people seated in 6 seats. So how many options do we have for seat 1? 6, then 5, then 4, 3, 2, 1, which is simply 6 factorial. So 6 factorial is simply 720. So there's 720 ways 6 people can be seated in the first 6 seats in a movie theater. At this point our learners wrote down the rule 2. And rule 2 says the number of arrangements of n different things taken in n ways is n factorial. Okay? Again, if you want to write that down, pause the video, and then we'll make your own note. Okay? Example 7. Example 7 is on page 311. They want to know in how many ways can 7 vacant places be filled by 10 different people. So what we did is we said, okay, how many bits would we have? We have 7. In 7 places. Okay, so it's 1, 2, 3, 4, 5, 6, 7. So how many options do we have for the first bit? 10. If one person is filling that, then from the listed amount of people is left, which is 9 options. Then we have 8, 7, 6 people to choose from, then 5 then. Of course, looking at this here, there are 7 vacant places being filled by 10 different people. So at this point you must remember that 3 people would not have placement. Okay? You put that in a calculator. There's going to be 10 times 9 times 8 times 7 times 6 times 5 times 4. This gives you 604,800. 604,800. Now, some of you are going to say, but I would like to use factorial. Okay? So the question is, what are we shortening to actually use factorial? We've got 10, 9, 8, 7, 6, 5, 4. I'm shorting the 3, the 2, and the 1. Now remember in mathematics, that line compared to the previous line is a discrepancy, is different. Now remember in mathematics, we don't change the value of anything, we only simplify. So, if we brought in the product of 3 times 2 times 1, then I must divide by the same product. With that, now will give us exactly what we have there. Not so? So if you look at the numerator, that is simply 10 factorial over 3 factorial. And our calculate this 10 factorial over 3 factorial is indeed 604,800. So how do we then derive something from here? We know that n is the number of people we have, okay, or number of items filling a position, and there are 7 placements. Okay, so what we say is, we say, okay, this could have actually have done was 10 factorial over 10 minus 7 factorial. Would have indeed have given us that. Alright. So, again, another rule we can add here, an important conclusion that can be made based on this result, is the number of arrangements in different things taken R at the time is given by n factorial over n minus R factorial. Okay. Again, that's the rule we can write down. Now we're looking at example 8. Example 8 is on page, I think I deleted it. Example 8 is on page 312. They want to know, we are told that there are 12 different singers that are hoping to occupy the first 3 places in the essay outlets. In how many different ways can the first 3 places be occupied? So as you know, not every contestant is going to be filling the top 3 places. So out of these placements, 9 of them are not going to feature, but they won't be in the first 3 places, 9 of them won't make it, in other words. Alright, so how many bits are we going to have? 3, because there are 3 placements. How many options do I have for bit 1? I have 12. The person that comes first can't come second or third, so the next option I have is 11, then 10. That's a simple calculation. So that would be 12 times 11 times 10. So it's 1,320. But remember that formula that we just came up with now. The formula says, and this is one of those questions where we can use the formula n factorial over n minus r factorial. How many people do we have? We have 12 people, so it's 12 factorial over 12 people minus the number of placements, which is 3. So it's 3 factorial. Which is 12 factorial over 9 factorial. Do we have to use this in red? No, if you understand it in black, no problem. But some of you, I'm sure, find it useful. Don't understand how to do it. Okay, so it's 1,302. Let's get on. This is where the Haram starts, okay? We're looking at example 9. Example 9 is on page, so the same page. 312. Okay. So consider the word lovers. I want to know how many 6-letter word arrangements can be made if the letters may be repeated. So in A, the letters may be repeated. So how many options do I have here? Well, how many bits would I draw? Since it's 6 letters, 6 bits. Letters may be repeated. So I have 6 letters to choose from. 6, 6, 6, 6, 6. So that is 6 to the exponent 6. Which is simply 46,656. 46,656. Let's look at B. How many 6-letter word arrangements can be made if the letters may not be repeated? So again we have 6 bits. Okay. How many options do I have for the first? 6, 10, 5, 4, 3, 2, and 1. Which is simply 6 factorial. And 6 factorial is 720. 720. Let's look at C. C says, how many 4-letter words can be made if the letters may be repeated? So, we'll have 4 bits. How many options do we have? We have 6, then 5, then 4, then 3. So, 6 times 5 times 4 times 3, 360. No. If the letters may be repeated letters, that is incorrect. 1, 2, 3, 4. That's 6 times 6 times 6 times 6, which is 6 to the 4. 6 to the exponent 4. So they give you 1,296. Let's look at D. D is the calculation that is made now. How many 4-letter word arrangements can be made if the letters may not be repeated? So, it's going to be 6, 5, 4, 3. Which is basically 6 factorial over 6 minus 4 factorial. 6 factorial over 2 factorial. Okay. Is going to be 360. People remember the note that was made in class earlier. We can't say 2 going to 2 once and 2 going to 6 twice, which gives me 3 factorial. That is never the case. Nor is 6 factorial over 2 factorial equal to 6 minus 2 factorial, which is 4 factorial. That's also not the case. Okay? I think that is behind the calculator means just take it away. Okay, that is never the case. Alright. Again, people, do we have to write it in this format? No, you cannot just put in the calculator 6 times 5 times 4 times 3 and you get 360. Okay, as I just said, it's just a useful tool for using, especially for those of you who is considering maths next year as well. Okay, that's example 9. Close out. So during the lesson, we actually did all the odd numbers from exercise 2 and the even numbers is homework. Okay, so again I'm going to do it quickly with you guys so that we're in conformity with what we have done in the previous lesson. Okay, again these questions was done with the learners, but there's no sound on that video. Okay, so I'm going to delete it. So this will be loaded in its place. Okay. So looking at number 1, exercise 2 on page 312. They want to know in how many ways can 8 vacant places be filled by 8 different people. That is simple. 1A. So it's 1, 2, 3, 4, 5, 6, 7, 8. 8 vacant places by 8 different people. So the first one, we have 8 options. Then 7, then 6, then 5, 4, 3, 2, 1. Which is simply 8 factorial. Why is it going down? Because of the 8, if I choose 1 for the first place, I only have 7 people left to choose from for the next spot that's on. So it's 8 factorial. That gives you 40,320. Alright, let's look at B. B says, in how many ways can 5 vacant places be filled by 15 different people? Okay? So again, this is that case where you can say it's 1, 2, 3, 4, 5. How many options do I have here? 15, then 14, 13, 12, 11. You can work that out, or we could have said n factorial over n minus r factorial, which is 15 factorial over 15 minus 4 factorial. Okay? 5 I can 1, 2, 3, 4, 5. Yes. Okay. So it's going to be 15 factorial over 15 minus 5 factorial. The 360,000? 360. I don't know why I wrote 4. It's 5. Or as I said, you could have said 15 times 14 times 13 times 12 times 11. Okay. Let's go to the next one, number 3. Okay, with number 3 we are told a school needs to employ 4 teachers out of a potential 20 candidates. In how many ways can this be done? So again, this is one of the cases, it's n factorial over n minus r factorial. So it's 20 teachers to choose, people to choose from, and 20 teachers to choose from, and there's only 4 placements. So it's 20 minus 4. So of course 16 of them won't be placed. They won't get the job. Okay. So it's going to be 20 factorial over 20 minus 4 factorial. So they give you 16,000 116,280 ways that can be filled. Or if you're that kind of girl that wants to go with the bits, there are 4 places, so it's going to be 20 people to choose from, then 90, then 80, then 70. Okay. Should give you the same answer. 20 times 19 times 18 times 70. We use 116,200. Okay. Okay, just give me a couple of minutes. The lesson of this afternoon, there was no voice on. There was no, the mic wasn't on for some reason. So I'm almost done with it. How did the exam go? Easy. As you can see, I'm almost done. Right? So I'll be now with you. Right, so number 5, we're considering the word wiskunde. Okay? The Afrikaans word for mathematics. So we are told that. So if you count how many letters are there in wiskunde, there are 8 letters. Okay? So for 8, we'll have 8 bits. Okay, so how many options? Okay, so in how many 8-letter word arrangements can be made if the letters may be repeated? So if the letters may be repeated, we have, in the first case, 8 options. Then, 8 again. 8, 8. So in other words, that would simply be 8 to the exponent 8. Which is 16,777,216. Look at B. B says how many 8-letter word arrangements can be made if the letters may not be repeated. So you can already see it's going to be 8 factorial. So do I have to draw the bits? No. Okay? So it's going to be, I have 8 options for the first one. The letters may not be repeated. So if I chose I, you can't choose it again. So it's 7, 6, 5, 4, 3, 2, 1. Okay. So that's simply 8 factorial. And 8 factorial gives you an answer of 40,320. Okay. Let's look at C. How many 6-letter word arrangements can be made if letters may be repeated? So 6 bits. How many options do I have in the first case? 8. Letters may be repeated. So 8, 8, 8, 8, and 8. So it's 8 to the exponent 6. And 8 to the exponent 6 is 262,144. Then D, how many 6-letter word arrangement can be made if the letters may not be repeated? So that's the type of the n factorial over n minus r factorial. So that would be 8 factorial over 8 minus 6 factorial, which is 8 factorial over 2 factorial. Okay? So it's going to be 8 factorial over 2 factorial. Gives you 20,160. Okay, or we could have used the bits and have said it's going to be 8 times 7, 6, 5, 4, 3. That also should give you the same answer there. 8 times 7 times 6 times 5 times 4 times 3. Okay. 20,160. Okay. Should be correct. Number 6 is the even numbers we're doing. No, odd. So number 6 is again part of the homework. Is there number 7? No. Right, so that's the video I'll be deleting. I think I started with the first one. in class, but for the next lesson we'll just start at 8. Okay. We'll first answer all the the even numbers in our next video, and then we will then do the example 10. Okay. Thank you.